All right, hello, my wonderful students. This is part 3 of foldable number 3. We have 3 functions here again for our piecewise function. So we're going to go ahead and start off by restricting our domain. So the first one is x is less than or equal to -4, and the other one also starts with -4 here. So we know our first restriction is going to be at -4. So we're going to go ahead and put like this little asymptote kind of ish line just to show that the graphs are going to go up to that point but not actually cross that line. And the next one, so 4 is less than x, which is less than or equal to 1, and then x is greater than 1. So these share a 1 as well. So we'll go ahead and put our second asymptote for this one here, just to show that the graphs or the functions here are not going to cross here or here, but they can include it depending on the actual function. And we're going to go ahead and graph this one in green. We'll grab this one in blue, and we'll graph the last one in purple. All right, so go ahead and start with the first one here. We have x is less than or equal to -4, which is here. Less than or equal to means that this is it's actually going to be included in the asymptote here. So, and then we have a constant of 3. So this is going to be y equals 3. So this is every point that y equals 3. So we're going to go up 1, 2, 3, but it doesn't exist over here. It only exists on this side. So we're going to go ahead and put a dot here. And we're going to go ahead and put an arrow straight across this way right there. Because for every single point here, -4, -5, -6, -7, -8, it's always going to be 3. All right, now we're going to go to our linear function, which is this one here. We see it has a slope of -1, so our m is equal to -1, and our b is equal to 2. So that means our y-intercept is here at +2, and at -4, it's going to be open-ended, but at 1, it's going to be closed-ended. So if we look at our slope, which is -1, or -1 over 1, oops, not over 0. We don't want to break the universe. -1 over 1, so we go down 1 over 1. Here it is open circle, but we can also write this as 1 over -1, which means we will rise 1 and then go over 1. Rise 1, go over 1, rise 1, go over 1, rise 1, go over 1. And this one is going to be, oh, I did it backward. This one is closed circle. Sorry about that. Closed-ended, and this one is open-ended. Open-ended, because if you look here, at the -4, open-ended. At the 1, closed-ended. So we're going to turn it a little sideways real quick so I can draw my line from there to there. Boom. So that is our second function. Now we're going to go ahead and go to our last function, which here is quadratic. So if you notice here, this was moved 2 units to the right. So we're going to go ahead and start 1, 2. And here, when it crosses, or when it's going to get up to the x is greater than 1, that means it's going to be open circle. We already have a closed circle. It's kind of big, so I'm going to make a big open circle to show that it's not included there. And we go 1 over 1 up. 2 over 4 up, and then it'd be 3 over 9 up, but 9's not on the graph, so we know we're going to actually cross about right there. So we're going to go ahead and go here. So this is our first one there, and then we go around about right there. And this would be our piecewise function for this one, or the way our graph looks for this piecewise function. And for this one, we have a constant, linear. You can put commas instead of, I don't know why I'm using slashes today. I usually put commas. And quadratic, piecewise function. Remember, on the foldable thing, this would be what you actually write on this side. But just for this format, I'm just going to put it out this way.